Welcome viewers, in this video we will see the solved problem in superposition theorem using AC voltage source. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Calculate the current through 2 ohm resistor of the network shown below using the superposition theorem. So the network is given here. There are two voltage sources available and resistor and inductors are available here. Here resistor and capacitor is connected. This 2 ohm is the load resistor. Our aim is to find the current flowing through this 2 ohm resistor using the superposition theorem. So we know that superposition theorem, if the two voltage sources are available, mean we need to consider one source at a time. We need to find the current. So based on that, current flowing through the 2 ohm resistor I equal to I dash and I double dash. I dash is nothing but current due to 5 voltage source only. We need to consider only 5 voltage source, that is 10 voltage source is removed. I double dash is current due to 10 voltage source only. Only considering 10 voltage source, that means 5 voltage source is removed. So in the step 1 we need to consider only 5 voltage source, 10 voltage source is removed, that is short circuited. In the step 2 we need to consider only 10 voltage source and removing the 5 voltage source, that means the short circuit. Now we'll go to the step 1, that is considering only the 5 voltage source. So step 1, considering only 5 voltage source and removing 10 voltage source, that is short circuited. So here the 10 voltage source is short circuited. Only we have 5 voltage source is available. Our aim is to find the current flowing through 2 ohm resistor. So we can use the Kirchhoff's voltage law, loop method, closed loop method. So this is the loop 1. Loop means closed circuit. This is loop 2. The current in loop 1 is I1, current in loop 2 is I2. So we can frame the equation for loop 1 and loop 2 using the Kirchhoff's voltage law, KVL. So first we will apply the Kirchhoff's voltage law to the loop 1. That is nothing but applied voltage equal to voltage drop. That is the Kirchhoff's voltage law, right? So here the I1, current I1 is flowing through the loop 1. So we need to find what is the current flowing through this 2 ohm, the inductor 2 and resistor 3 ohm and this resistor 5 ohm and this capacitor minus 2J, right? So in this, here the current I1 is flowing through this inductor and resistor. So that 2J into I1 plus 3 into I1. In this 5 ohm resistor, this I1 is flowing as well as I2 also flowing. This arm is available between loop 1 and loop 2. I1 is flowing from top to bottom. I2 is flowing from bottom to top. Both are in opposite direction. So the difference in current I1 minus I2 is flowing through this 5 ohm resistor and this capacitor. So that it is 5 into I1 minus I2. Similarly minus 2J into I1 minus I2. That is equal to voltage source 5 ohm, 5 voltage. Right? So in inductor and resistor only I1 is flowing, but this resistor and capacitor I1 also flowing and I2 also flowing in opposite direction. So we are taking I1 minus I2. So after simplification we got 8I1 minus I2 of 5 minus 2J equal to 5 voltage. So equation number 1. We have I1, I2 into equal to voltage. Now we will apply the Kirchhoff's voltage law to the second loop. The second loop again this 5 ohm and this capacitor having two currents are flowing. In this 2 ohm only I2 is flowing. So 2 into I2 plus 5 into I2 minus I1. Here we are taking I2 as a reference. So that I2 minus I1. In previous loop I1 is reference. So I1 minus I2 minus 2J I2 minus I1 equal to 0. There is no voltage source in the second loop. So that is equal to 0. So after simplification, what we got? Minus 5 plus 2j I1 plus 7 minus 2j I2 equal to 0. Right? So we have equation 1 and equation 2. Now we need to solve this equation 1 and 2 for the further simplification. So this equation 1 is written 8I1 minus 5 minus 2j I2 equal to 5 minus 5 plus 2j I1 plus 7 minus 2j I2 equal to 0. Now we can write in a equation, a matrix format. V equal to I into R. Voltage matrix, current matrix, resistor matrix. So this 8 is written here. Minus is written, minus is multiplied out inside. So minus 5 plus 2j equal to into I1 and I2. Here 5 voltage is there, here voltage is 0. The second equation, minus 5 plus 2j, 7 minus 2j. So this is now the resistor matrix, this is current matrix, and this is the voltage matrix. Now we can find the delta value. This delta value is calculated here. So this is nothing but delta. We need to find the determinant. You have to multiply these two. 8 into 7 minus 2j minus of minus 5 plus 2j into minus 5 plus 2j. You have to multiply this. So after multiplication we got this value. We can go for further simplification. So for further simplification, delta equal to 56 minus 16j minus of minus 25 minus 20j plus 4 into minus 1 is multiplied. So after fully simplified, it is got 35 plus 4j. This is the rectangular form. It should be converted into polar form. That is, this is real term and imaginary term. This one angle, this magnitude and angle 35.22 with an angle of 6.51. How to convert this rectangular to polar? It is available in a calculator. In the calculator directly you can calculate, you can convert from rectangular form to polar form. Manually how to convert? This magnitude is nothing but square root of these two values, real and imaginary term. Square root of 35 square plus 4 square. So that is nothing but this 35.22 value. Similarly, the angle, how to convert? Tan inverse B by A, that is imaginary term by the real term. 4. Tan inverse 4 divided by 35. So that is nothing but 6.15 degree. So rectangular to polar directly you can convert from calculator or manually mean this is the formula. Square root of square of the values and angle tan inverse B by A, 4 by 35. Now we'll go to the delta 2. Delta 1 is not needed. What we need is I2. I1 current is not needed. So directly we can go to delta 2. Delta 2 means the second column is replaced by the voltage matrix. This is the first column written as it is. Second column is replaced by voltage matrix. So 8 into 0 minus 5 into minus of minus 5 plus 2j. Right? So after simplification we got 25 minus 10j. In a rectangular form. In polar form it is 26.925 with an angle of minus 21.8 degree. So here also we can convert by using this formula. The same thing what we discussed. Square root of square of the magnitudes. Tan inverse B by A. Now we calculated delta 2 also. Now we can calculate I2 value. From these two we can calculate the I2 value. I2 equal to delta 2 divided by delta. For the division we need a polar form. Rectangular form is used normally for addition and subtraction. For this division and multiplication normally we need the rectangular form, polar form, so that it is easier. So delta 2 is 26.925, angle of minus 21.8. Delta value is 35.22, angle of 6.51. So these two magnitudes are divided. 0.764. Angle we have to subtract. This angle is subtracted from this angle. Minus 21.8 minus 6.51. Multiplication means these two angles are added. Division means subtracted. That is the procedure. Right. So after subtraction what we got? Minus 28.31. 0.764 with an angle of minus 28.31. So this is the current. Therefore, current through 2 ohm resistor due to 5 voltage source only is nothing but I1 dash, that is equal to I2 equal 0.764 with an angle of 28.31. So this can be converted into polar form. This is polar form, rectangular form. 0.672 minus j 0.362. Here also directly you can convert from the calculator. Now we'll go to the second step by considering the 10 ohm 10 voltage source. Considering only 10 voltage source by removing the 5 voltage source, that is short circuited. See this, the 5 voltage source is short circuited, only we can consider the 10 voltage source. Again here we can use the Kirchhoff's voltage law. This is the loop 1. This is loop 2. In loop 1 the current is I1. In loop 2 current is I2. First we will apply the Kirchhoff's voltage law to the loop 1. So here we have inductor and resistor. Only I1 is flowing through this inductor and resistor. So 3I1 plus 2j-I1. In this resistor and capacitor, as we discussed earlier, the I1 also flowing, I2 also flowing in opposite direction. So that 5 into I1 minus I2, this in this resistor. Capacitor minus 2j I1 minus I2 equal to this voltage source, 10 voltage, right? See this, the polarity top to bottom, negative to positive, right? The current is flowing from top to bottom, positive, negative to positive, rise in potential. So that 10J. So after simplification we got 8I1 plus 5 plus 2j-I2 equal to minus 10J, right? This is minus 10J. This is equation number 1. Similarly, we can apply the Kirchhoff's voltage law to the second loop. In the second loop, in 2 ohm only I2 is flowing, 2 into I2. But again this resistor and capacitor both I1 and I2 is flowing. So I5 into I2 minus I1. Here we are taking I2 as a reference. In loop 1 I1 as a reference. So I1 minus I2. Here I2 minus I1. Similarly the capacitor minus 2j I2 minus I1 equal to 10j. Right? After simplification what we got? Minus 5 plus 2j I1 plus 7 minus 2j I2 equal to 10j. This is equation number 1. Right? So now we can consolidate this equation 1 and 2. 8I1 plus 5 plus 2j I2 equal to minus 10j. Minus 5 plus 2j I1 plus 7 minus 2j I2 equal to 10j. So it is written in a matrix form. This 8, this 5 plus 2j, minus 5 plus 2j, 7 minus 2j. I1, I2 equal to minus 10j and plus 10j. So this can be formed. This is V equal to I into R. Voltage matrix, current matrix and resistance matrix. Now we will go for the further simplification. So in the loop 1, current is flowing downwards. I1 is flowing downwards from positive to negative. So that minus 10j. In second loop, I2 is flowing from bottom to top, minus to positive, rise in potential. So plus 10j. Right? Loop 1, current flowing downwards, positive to negative, fall in potential. In loop 2, current is flowing from bottom to top. See the current is flowing bottom to top. Minus to plus, rise in potential. So that 10j. Now we can go for further simplification of this matrix. So this is the del. The resistor matrix is the del. So 8 into 7 minus 2j minus of minus 5 plus 2j into minus 5 plus 2j. You have to multiply this. After simplification we got 35 plus 4j. So it is in a rectangular form. That can be converted into polar form. 35.227 with an angle of 6.519. So we already discussed how to convert from rectangular to polar. Directly you can convert from calculator, or procedure is there. Square root of 35 square plus 4 square. This angle is tan inverse 4 by 35. This delta value is very similar to step 1 also. Now we will go to delta 2. Delta 1 is not needed. I1 value is not needed. What we need is I2. So directly we can go to delta 2 value. So 8 minus 5 plus 2j. This second column is replaced by the voltage matrix, that is delta 2. First column we replace delta 1. So 8 into 10j minus of minus 10j minus 5 plus 2j. So after multiplication, after simplification, we got 30j minus 20 in a rectangular form. While converting polar form, it is 36.055 with an angle of 123.69. So this is the delta 2 value. From that we can calculate I2 value. Delta 2 divided by delta 36.055 angle 123.69 divided by 35.227 angle 6.519. I already told, for division or multiplication polar form is necessary. For addition and subtraction this rectangular form is necessary, easier. Rectangular form is easier, polar form is easier for division and multiplication. So these two magnitudes are divided. 36.055 divided by 35.229. So it is 1.023. The angles are subtracted. 123.69 minus 6.519, that is 117.171. So this is nothing but I2, current due to only the 10 voltage source, minus 0.469 plus j 0.91, right? So that is in a rectangular form. Again it is converted into rectangular form. I2 equal to I2 dash. So the total current flowing through the 2 ohm resistor is I dash plus I double dash. This I dash is already calculated. I dash is already calculated in the step 1, 0.672 minus j 0.362. I double dash is calculated here, 0.469 plus j 0.91. So by adding these two, 0.205 plus j 0.547 in a rectangular form. Polar form it is 0.564 magnitude of the current. Angle is 69.45 ampere, right? So this rectangular is converted into polar so that we can get magnitude and angle. So this is the total current flowing through this resistor 2 ohm due to 5 voltage source as well as 10 voltage source. So in this problem we discussed the superposition theorem, the AC source having the AC source having with two sources. We consider the first source, calculated the current, then we consider only second source, we calculated the current, then both are added together. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.